Chapter 5. Alrighty, this next chapter has to do with working with radicals. Now, radicals really simply mean square roots. Well, square roots, cube roots, fourth roots, different kinds of roots. So basically, that's all we're going to say. A radical is just a fancy name for roots. So these are roots. And they're usually accepted as exact instead of using a rounded decimal. Yeah, decimals that go on forever, that's not really exact. But so if they say leave it as exact, they mean leave it as a square root. So for example, square root of 5 is exact. The decimal equivalent goes on forever. 3 times the square root of 2 is exact. Now careful, this is 3 multiplied by the square root of 2. I could also do the cube root of 2. That means different, right? So what number times itself 3 times would give me 2. So notice, this is called the root index. Okay, yeah, so here it's a full number. So it's like 3 multiplied by, so it's a whole number. So if the root index, now if the root index is a small number, like the 5th root of 148x squared, yikes. The entire radicand is inside. This is the root index. Now careful, if there is no root index, we assume it means 2, right? Square root of 9, I'm assuming that means the square root of 9. So a radical may have 2 different parts, right? So this is called the radicand. Hang on, so the radicand, the inside. And you've also got a root sign, the root sign, or the radical sign. And this is actually called the root index. What kind of root is it? The index. Square root, cube root. So evens and odds. Oh yeah, and because of negatives, you're going to have restrictions on the radicand, the inside, depending upon the root index. So in other words, even roots cannot have a negative. Oh, I remember that. Cannot have a negative radicand. So in other words, the inside, right? But if it's an odd root, they can have, may be positive or negative. Yeah, because like if you had a cube root of a negative, it turns out to be negative. The result will be negative. Yeah, so if it is going to be positive, it's going to be positive. If it's negative, then it's also going to be negative. So they can be positive or negative, right? But even roots, only going to be positive. So give restrictions. So in other words, the inside part here, the 2x plus 1 has to be greater than or equal to 0. Now it could actually equal 0 because square root of 0 is 0. So now I'm going to move over the 1. This becomes negative 1, and I'm going to go divide by 2. So in other words, x is greater than or equal to negative 1 over 2. Any number bigger than negative a half would work. Anything bigger than negative half is going to work. If I chose something that's smaller than negative half, like negative 1 or negative 2, I would end up with a negative, and I got a problem. Cube root, there are no restrictions. What? Nope, none whatsoever. This could be positive or negative. No problems. So yeah, just like fractions, they might be mixed. You could have a mixed fraction like 3 3/4, right? Or it could be improper. Oh yeah, an improper fraction, I would go 3 times 4 is 12, plus 3 more is 15 quarters. These are the same thing. This is 3.75, this is 3.75. How did I get that? I went 3 times 4. In other words, I made it 12 quarters plus 3/4. Oh, I remember that. Yeah, so that's if you're going to be turning an improper or a mixed fraction back and forth. So in the same way, this is mixed. It has a whole number and a fraction. Improper, the entire thing's a fraction. So just like that, radicals could be mixed. It could be mixed like this. 2 times the square root of 5. So 2 root 5. Or they're also called entire. This is where the entire thing is a radical, like root 20, for example. So how do I turn a mixed into an entire? That's the easy part. Yeah, this one's not that bad. Okay, so here's what we're going to do. I'm going to square this first number. 2 times 2 is 4, and multiply it in. 4 times 5 is 20. There we go. What? Are you kidding me? They're the exact same thing. Watch. Whoa. Let's try this out. 2 times the square root of 5, which is like 4.4721. That's a decimal, but it goes on forever. What if I do the square root of 20? It's the exact same thing. So this is just 2 different ways of writing the exact same number. So how did I do that? Easy part here. I square the first number. So I square the whole number. the whole number and multiply it in. Well, it's kind of a shortcut. Look, if I go 2 squared times 5, I'm going to get 20. So square root of 20, and that's what it is. Really, here's what I'm doing. I'm taking the 2 and I'm turning it into the square root of 4. Right, because that's what it is. And then square root of 5. Really, that's what I'm doing. I'm not showing that step. I'm just going 2 squared is 4, 4 times 5 is 20. So same thing. 3 root 6, 3 times 3 is 9. So this is like saying square root of 9 times the square root of 6. I usually don't show that step. And I know 9 times 6 is 54. Root 54. So this number and this number are the exact same thing. Here it's a mixed radical. Here it's an entire radical. Negative 7 squared is 49. I'm just going to square this 7, not the negative. 49 times 3. Okay, hang on. What's 49 times 3? 50 times 3, 150, take away 3. So it's 147. Square root negative. The negative has to stay out front because it's a negative number. This is what this means. If I square that and put it in, it becomes positive. I want it to be a negative number. Oh, this one's cubed. Well, it's not 2 squared times 5. It's going to be 2 cubed. Okay, well, let's try that. So if it's a cube root, I'm going to go 2 cubes. So this is going to be like saying the cube root of 2 times 2 times 2 is 8 times the cube root of 5, right? Because 2 is the cube root of 8. Cube root of 5. 8 times 5 is 40. So this is cube root of 40. Oh, okay. What if it's got x's in it? Well, same thing. You can still do it, but it's just going to have an x in it. So you're going to have x squared times 25, or 25x squared. Hang on, let's get this thing to work here. So this is going to be the square root. Let's get this to work. This is going to be the square root of 5 times 5, 25x squared, times the square root of 6. Now, 25 times 6, that's 150. So this is the square root of 150x squared. This is the exact same thing. 5 times the cube root of 2. Okay, so instead of 5 squared, it's going to be the cube root of 125. There's 5, right? 5 times 5 times 5 is 125. Times the cube root of 2. Cube root 2 times, this is going to be the cube root of 250. Whoa. 4 times the 4th root of 4. Okay, this is going to be complicated. So what's 4 to the power of 4? 4 times 4 times 4 times 4, 16. This is 256. 256. Whoa. So the 4th root of, so the number 4 became the 4th root of 256 times the 4th root of 4. So really I'm going to go 256 times 4. That's 1,024. And it's going to be a 4th root. Hang on, is that right? Here's how I can check it. How do I do a 4th root on my calculator? If I go to math and it's down here, it's this one. There. Oh, but hang on, I have to put in the 4 first. Okay, so here we go. 4. And then I'm going to go math down to here. There we go. So it's the 4th root of 4. Boop, times 4. Multiply that by 4. So I get 5.65685, blah, blah, blah. Okay, is that the same as the 4th root of 1024? Let's try it. 4, and then math 5. 4th root of 1024. It's the exact same number. Okay, so here it's written as a mixed radical. Here it's written as an entire radical. The entire thing is a root. Here only whole number and part. Okay, so if it says rearrange the radicals from least to smallest, I could turn all of these into decimals. Yeah, because these are all going to be roots. Another way I could do this is I could turn them all into entire radicals. What? What do you mean? 5 times 5 is 25. 25 times 3 is, this is like saying the root of 75. These are all square roots, by the way. 3 times 3 is 9. 9 times 10 is, this is like saying the square root of 90. I know that this one's bigger than this one. What about this one? A half times a half is a quarter. What's a quarter times 320? So in other words, 320 divided by 4. This is like saying the square root of 80. There we go. Smallest, medium, largest. There's the smallest one, there's the middle one, and there's the largest one. That's what they are, from smallest to largest. So going from mixed to entire is not that bad. You just square the number. Here's the harder one. Entire to mixed, way harder. Here's what I need to do. I need to express as a product of a perfect square. So a perfect square number and another radical. Y, another radical. Then I'm going to simplify. What do you mean? Let's try it. This means you need to recognize your perfect squares. So what are the perfect square numbers? Remember those ones that we keep saying, oh, remember these, you're going to recognize them. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 49, 81, 100. 11 squared is 121, 144, 169, that's 13 squared. Then they switch, 196, 14 squared, 225, 15 squared, 256, 289, that's 17 squared, 324, 361, 20 squared is 400, 441, 484. Yeah, go. You know what? The first 15 or so, right up to around here, those are the ones you're going to recognize. 20, I recognize that. It's 4 times 5. So it's root 4 times root 5. Now I notice I put the perfect square first because I know that the square root of 4 is 2. So this is 2 times the square root of 5. Done. Oh yeah, we did that one before. How about this one? Root 72. Now I could make that 4 times something. I could make it 9 times something. But why don't we go for 36? That's the biggest one. So I can do this as root 36 times root 2 and also root of x squared. I'm going to break this up as 3 different parts. 72 is going to be 36 and 2 and square root of x squared. Now, the square root of x squared is just x. This is root 2 and this is 6. So it's going to be 6 times root 2 times x. Now, you know what? We'll probably write it as 6x root 2. But they're the exact same thing. They usually put the root at the end. Okay, 320. Okay, how do I break up 320? 4 times something. Yeah, I can make it 4 times 80. 16 times something, I could make it 16 times 20. 25 doesn't divide in. 30. 64. Oh, I missed 64. 64 is in here. 64. This is root 64 times root 5. Now, I could have done it as other ones, 16 and 20, but it would have taken 2 steps. Okay, let's try this. This is 8 times the square root of 5. So if you recognize these numbers, your life becomes way easier. Oh, what if it's a cube root? Okay. No problem. I'll use the cube numbers. 1 cubed is 1. Well, that's kind of useless. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And then they switch to 16. 6, 24. I know it's got to be this one. So this is the cube root of 8 times the cube root of 3. Right? 24 is 8 times 3. Factor it. I put this one first because this is going to become a whole number. This is the number 2. 2 times the cube root of 3. So some people would have said, hey, why don't you do this? Cube root of 12 times the cube root of 2. I could have, right? 24 is 12 times 2, but this is useless because I don't know the cube root of 12 and I don't know the cube root of 2. I do know the cube root of 8. That's why I chose that one. Cube root of 250. Oh, man, that's a big number. Boop. Not if I have these written out. I know that's 125 times 2. Cube root of 125. Cube root of 2. So this becomes 5 times the cube root of 2. Okay, square root. What do we got? 216. 216, that's 4 times something. It's 4 times 50 something. Hang on, isn't that 36? Oh yeah, 36 times 6. 36, 6. X squared, x squared, x. Why would you write it in such a silly way? Because x to the power of 5, I really know that means x squared. This is x times the square root of x. This is the root of 6. This is 6. Okay, so here's what I got. 6 times x times x. I've got 6x squared. Inside the root, I still have a 6. I still have an x. 6x. See, I can break this down using x's and also using numbers. I can do them as 2 different parts. Now, you don't have to do it this way. I could have recognized, hey, there's 5 x's. I can take 2 of them outside, and I'm left with 1 inside. Yeah, so when I take out 2, that really becomes x to the 4. That goes out front. Okay, so there is our first assignment. This really has to do with entire to mixed and mixed to entire.